Hello, everybody. We're just waiting to get everything up and running. So we'll have Carly go ahead and start the show, but she's currently getting us all set up on both LinkedIn and YouTube. So just give us a few minutes to get ourselves up and running. Meanwhile, just to get things all warmed up, why don't we talk about, and you can chime in the Q&A panel, by the way, where you're based out of. For example, I'm based out of the sunny Seattle. Oh, sorry. I basically let the YouTube thing on the background happen. So I'm based out of sunny Seattle, and I'm not being facetious. It's actually sunny. So woohoo! All right. How about you, Robert? Where are you based out of?
I'm based out of today also sunny Mannheim, Germany. Maybe our US listeners know Heidelberg a bit better. It's quite close to that. Yeah.
Awesome. I'm based in sunny St. Petersburg, Florida.
Awesome. St. Pete's. I've had good young memories of St. Petersburg and St. Pete's Beach. Okay, cool. Well, I think we're on for LinkedIn, and I believe we're on YouTube. So, Carly, whenever you want to, we can take it away.
Great. Thank you, everyone, for joining us today for another Delta Lake Discussions with Denny Lee, also known as D3L2. Today, we have Robert Pack, who is a senior digital expert, cloud native machine learning, platform and technology principal. Woo! That's a mouthful.
Yeah. That's one heck of a title, buddy.
It's true. And I also live quite close to a church. I'll just, because that's going to be going on for a couple of minutes now. I'll just close the window really quick.
Oh, yeah, that's probably a good idea.
Awesome.
Ladies and gentlemen, this is what happens when we do everything live.
Robert is with BASF, and today he will be discussing with Denny the relationship between process engineering and data engineering. And with that, thank you all very much for joining us today. I will pass it over to
Perfect. Well, thank you very much, Carly. And thank you very much to the church in the background for giving us some background music. So let's start the show. If you all don't remember what the purpose of this vidcast and podcast is, it's just so we can constantly renege you on Delta Lake. There's actually a lot of truth to that statement. But in all seriousness, the reason we wanted to actually have a conversation today with Robert is because he's been very heavily involved with the Delta Rust project. And so because of that, we're going, hey, why is a guy from, Mannheim, outside of Heidelberg, Germany, talking to us about Delta Rust? That seems like a weird thing. And of all places, BASF too. It's like, wait, that's interesting too. So let's dive into it, but then let's go backwards a little bit. And don't worry, I'm not asking you to tell me about your baby time, when you're a child here, but I'm just curious, what got you involved even into this space? Like, where did you study? Like, what were you studying? I'm just curious. Let's start at the college or university level, basically.
Absolutely. So I studied something called process systems engineering, a subdomain of process engineering, and I studied in Aachen, also where I was born, a city in Western Germany, and maybe better known at London Imperial, and had some great teachers there. So essentially, when you talk about process systems engineering, it's not sort of the low-level stuff where you look into individual units, reactors, columns, what have you, but more on the whole process optimization and control level. So quite early on, the laboratory was a computer, and you needed to write code, sort of on the solver level to, well, get your questions answered. And this also kind of set me on a path to think in systems, kind of, yeah. At a certain point, you just look at sort of an abstract volume with kind of flow in and out, and stop giving it a name. Everything is just an A or delta or whatever. Deltas actually occur quite frequently.
Yes, but in this case, just to confirm, we're talking about deltas in the context of process engineering as we're starting. We're not quite at the delta lake level yet. Exactly.
We're talking about delta as an operator in in functions. Yeah. So yeah, and this is something I got quite excited about. Yeah. So optimization and looking into systems, well, just kind of resonated with me on some deeper level, I guess.
So actually, let me just focus on that little part too, because there's actually a little call out about like process engineering. So yeah, I mean, there's a lot of people that might not actually are familiar with that concept, because we're actually starting this conversation not from a data engineering or like, delta lakes or data lakes, or we're not talking about that. Actually, we're talking about actual engineering. So I'm just like, can you provide a little bit of context? And like, because again, we've discussed this before, so I understand the idea of solvers, but yeah, maybe provide a little context of like some examples of what you're talking about, because it's directly related to what you're doing as it is anyways. So
certainly. So at BASF and other chemical companies, so essentially when you see and you'll see kind of the first graphs and natural structures emerging from what comes next. But we take carbon in the form of oil, gas, coal. Actually, we try to not to do coal. Then we crack it in something called the cracker, and it's sort of little pieces. And then we start to reassemble it into all the complex molecules that go into everything from, I don't know, construction materials, plastics, pharmaceuticals, agriculture, essentially everything. So that tree goes up, and companies like BASF sort of feed into virtually all value chains. Yeah. And these networks that sort of emerge also happen on a lower level. So how do you do a reaction? How do you do a separation? Yeah? Because I mean, have you ever tried to mix milk and water? Well, that's easy. But then have you tried separating that again into milk and water once you mixed it? That's sort of not so trivial, but we do this a lot sort of in the chemical industry. And process engineering, since this is also bound by the laws of thermodynamics, quite energy intensive, we try to, well, find optimized ways to do these things, to create the products, and especially in these times, but generally also be as efficient about it when it comes to energy in the end, because energy is both ecological and economical constraint often.
No, I like that, because I mean, just to remind everybody, the title of today's session was how BASF achieves global sustainability with Delta Lake, right, with Robert Pack. And that's a really important call out here, that we're starting within the context of process engineering, taking chemicals, breaking them down, putting them back together. Everything, all the materials that we are typically using, from videotapes to the clothes to whatever else, to textiles, all the stuff, I figured it's okay for me to toot BASF's horn, so that way you don't have to, right? BASF actually is involved with, like, a lot of the materials. Maybe they're not building the end material, the end result that you're used to seeing, though admittedly enough, I'm old enough where I still remember BASF VHS videotapes. Okay. Yeah, okay. So, all right, but that's
actually, well, one of the very few. There's a couple of end consumer facing products in South America, but when you say BASF, some people have no idea what you're talking about.
Right.
And some people say, oh, yeah, the ones who you produce the cassettes and VHS cassettes. We're like, yes.
Yeah, exactly. It's like, yeah, that's one thing. Right. Right. And that's most of the context. But so the whole point is that there's an entire chain of materials that are generated by BASF. It's a gigantic company, and exactly what Robert's calling out, both from an environmental aspect and also from an just as importantly an economic aspect, or if you want to do the where, just both from an economic perspective and just as importantly an environmental aspect. BASF's got to figure out how to do this efficiently. That's what it boils down to. Okay, and then we'll eventually get to Delta Lake, by the way, but. Yeah, like literally, this is actually really cool if you think about it. Like this, that we're actually talking about actual end process engineering. So, all right. So why don't we talk about that within the context of pipelines then. And because I love that discussion that we had. And by the way, we're still not talking about data pipelines for everybody. We're talking about actual pipelines, okay? Actual mechanisms to produce said materials. And so, yeah, well, so you obviously got into process engineering. That makes a lot of sense. How did then you join BASF and start doing this type of work? I'm curious.
Well, scale. So one of the things, so one of the keywords that BASF kind of uses is connected. Yeah, everything is connected.
Yeah.
And if you work at BASF, you also have to get familiar with one word, which is Verbund. It's
Verbund, right.
When I was doing exchange year in the US, everybody came along and it's like, Robert, what's Puffergnügen? I'm like, I don't know what you're talking about. What they meant to say was Fahrvergnügen, which I guess VW did some commercials back then, which is the joy of driving, Fahrvergnügen, yeah. But they kind of expected people to just know that term. And in BASF, something similar happens with the term Verbund. Verbund just means you don't take a single plant that operates on its own, but one kind of production facility's waste may be another production facility's product or raw material rather, right? There's processes that emit a lot of energy, and there's processes that use a lot of energy. So try to get those together, and you achieve a lot of sort of sustainable growth, kind of utilizing and not wasting any valuable streams, be it energy or materials. And BASF operates the biggest Verbund, yeah. And that's what kind of drew me to it, because there's a huge lever, and also they're committed to this goal, yeah. And I'm not kind of Gen Z, but I'm from the generation that already cares a lot about the environment and all of this. And I felt like, okay, there you may be able to have an impact and do your contribution. Yeah? And in the end, everything on those sites, and in Ludwigshafen where I work, it's several hundred plants that are interconnected, exchanging materials, consuming energy, I don't know, exchanging all of this. So a big complex network of things, yeah? Which is where we kind of start to make the link to the data domain, because obviously, so I went into the digitalization branch of things, yeah. Yeah, I was just kind of thinking, do we want to go into that transition as well?
Oh, absolutely. Yeah. No. We absolutely want to make that transition. I mean, yeah, because this is what I'm saying. Like, if you think about it from the standpoint of process engineering, from where you're coming from, like the fact is, just like, just to throw out my own history, right, a little bit, right? I was supposed to become a doctor. Okay, typical Asian parents, typical Taiwanese parents. So that meant I was supposed to become a doctor. So how the heck did I become a Delta Lake maintainer, right? And the story's not about me, so I'm not going to finish it. But the context is, there's an interesting set of paths that basically led me to where I am now. But what's super interesting about your path is that there's a lot of parallelisms or a lot of similarities between the exact processes that you run and what we do today in data, as it is anyways. So yes, that transition is actually super interesting, because it's like, well, yeah, like you were doing process engineering. You didn't, like, why would I care about querying data, like, and then eventually into why Rust, like it's the whole thing here, like it doesn't seem it's supposed to be connected, but in fact, after based on our discussions in the past, right, there's actually a lot of association, which is really, really cool. So yeah, so that's the context. Yeah. So yeah, like, yeah, so you're doing process engineering, you're there's this concept of a Verbund, you're seeing how all these things are connected, which invariably led to saying, hey, we got to pass data back and forth so we can actually understand how we're actually supposed to do these processes. So yeah, kick it off from there.
Yeah, and I mean, scale is actually one thing that's different. So my assumption is I'm certainly not much smarter than the people who did the same jobs 30 years ago, 50 years ago, right? So what's different? Why can we outperform them who worked on this for decades and decades and decades and decades? And to me, the answer is scale. Scale in the sense of what can we do with processing right now, right? So if you look into some of the old codes, they're written with, okay, I need to save every byte of memory. I can only process what have you. And these days, that's just not a limitation anymore. What that meant for me was, okay, we did our analyses always on a sort of fairly low level, but we can lift that up to a higher level where others couldn't kind of work before due to the limitations of their time.
Right.
Yeah. And in the end, you then need to start to look into, and this is why, I mean, that's actually one thing that Delta already does. It says metadata is just as important, and actually in it of itself, a big data problem. And we felt, not only we felt that the same is true elsewhere, right? I mean, you need to manage your metadata, you need to reason about your environment. And I think also when you talk about AIs and stuff, you need to provide context. Yeah. To me, that's just sort of another word of saying you need to provide some metadata on where you are, where you're moving right now, what's kind of the system you're looking at, all of these sort of things. So my transition then into the digitalization domain was purely driven by, okay, we were solving problems from the numerical side, from the simulation side. And if you look into, and this is a gross oversimplification, but if you look into machine learning and then say, okay, replace, don't call your matrix a matrix, call it a table. And well, you essentially go from the numerical field into the data processing field a bit, but then if you go into the actual training, you're again looking at optimization algorithms. That's something I had been doing for many, many, many years and many, many different variations. There's different optimizations that are going on, not necessarily more complex, but you offer it much more data and you do so. So this was how there was a natural transition. And then we started looking into some of the things where we felt, okay, how can we create value from this for BASF? And we went down a path many different companies also went down, which is, okay, how do we get the data? It's nice, yeah. We know we have it, but do we have it kind of ready to be queried? And sometimes the answer was yes, sometimes the answer was no. But here, exactly sort of that graph thing, this tree structure starts to map to a pipeline, right? Because whenever we move stuff in between pipelines, that's your edge in your compute graph, right? Every unit, every plant, it's just sort of a function you apply to your material, and then you get an output. But also every node everywhere sort of generates data, right? So every unit, every interaction generates data, and that needs to be surfaced and collected somehow. And I'm not someone who has done much work in things like e-commerce or anything, but I always envy them for one reason, because it's already digital to begin with. So if you collect your data, I'm not saying it's easy, but I am saying you are already in the digital domain. The data is generated digitally. And if you're willing to put in the work, there is a way for you to collect and process that. Some of these questions were unanswered for us. Yeah.
So I'm curious, actually. So, as you go from like chemical engineering Fourier transforms, to the standard machine learning algorithms to, Bloom filters, right? I mean, you're right. The math is still the same. It's just that the application of these different models, that's all it really is. But then I'm curious, since you're talking about loving e-commerce, and I completely agree, by the way, like I was one of those folks that basically said, follow the trends of web analytics and you'll understand where we're all going to go when it comes to scale. And I said this back in, I guess, like the late 90s. I'm old. Okay. So, and the whole reason is because exactly to your point, is that it was already digitized. We just had to figure out how to basically make sense of all this digital data. That's all this is. So in some way, like, did you basically were you able to like add components to get digital information, or is it like literally export data from the spectrometer, import in CSVs? Like, I'm just curious, like, what was that transition for you like, or because I doubt it was like one of those like IoT style plays where like, oh, I just put a module in and everything magically feeds into your system, basically. So.
Absolutely not. Absolutely not. The answer is all of the above.
Okay.
I mean, at a company that size, sometimes we have very highly digitized environments, where all experiment data, all production data is beautifully collected, maintained, and then there's other places where it's the Wild West, and you're almost dealing with handwritten notes. So all of the above. I do want to say that I think, and this is sort of an effort across the company, and we've been advocating that, but making data available and accessible, that has been a phenomenal journey. And actually Delta, to me, is an integral part of this. I mean, not only because sort of Databricks unlocked a lot of the things that you otherwise needed to do yourself in the cloud. But yeah, that's how I got into digitalization.
Okay.
And then we can kind of go from there to how did we go into Delta?
Yeah, exactly. So that's perfect. So So what's interesting is that it also started. Actually, correct me, because actually I forget this one. Like, did you start Databricks before Delta, or did you start Delta before Databricks in this case?
Actually, I'm a little bit proud because our project team, we were the first, not the let's say most intensive users over time, but the first users of Databricks within BASF, and it was sort of right after it may have been part of the public preview. I think that's when we came into.
Oh,
so
cool.
Back then we were processing a lot of data, and let's say technology wasn't quite ready for what we wanted to do, in a sense that, I don't know if you remember stuff like, I think it was called machine learning server or SQL machine learning server or something, and based on R and this XDF file format or
something.
something.
My goodness, yes. Yes, it was after my time at SQL Server, because this is when they purchased the Continuum or something like that, like the company that was basically pushing R. Yeah. It was after my time there, but yes, I definitely remember that. Yeah.
And
yeah.
running this distributed was no fun.
Yeah.
Let me put it.
Let's be nice, but yeah, like we'll leave it at that.
Yes. And then obviously we knew about Spark, but setting up Spark manually also wasn't something that.
Oh, come on, it's easy. Don't you want to modify all those config files and know every single configuration? Come on, it's fine. Don't you know that you're supposed to set the Spark.executors? Yeah, no, sorry. If you can't tell everybody that's listening here, we're being very sarcastic. No, this is not an easy thing to do. I love Spark, obviously, right? You know, like so, but it's configuring could be tricky at times.
Yeah. And then actually Databricks came along, and that was a whole different experience. Yeah, we could run a lot of queries against fairly big data sets, and we're very, very happy with it. So that was the first context. So Databricks was definitely before Delta, because I think Delta did not exist at that time yet. I think Delta,
if we're at the public preview, then we're talking about 2015-ish, I think, right? Or 2014-ish for Databricks, and then Delta.
Azure Databricks, though, it was Azure Databricks. I think AWS.
Oh, Azure Databricks then would have been a little bit later. Yeah. Then okay, but then still, you're right. Delta would have been after that, anyways. Yes.
Yeah. But from then on, actually, Also, I ventured a little bit into doing actual Scala because we mentioned graphs already, right?
Yeah.
So me as a naive young person be like, okay, let's just use the Spark graph APIs, which were back then only available in Scala, and do some
The GraphX. Oh, that was so fun.
do some distributed graph really quick. That was also fun.
Oh yeah.
But it teaches you a lot. It teaches you.
It does, yeah. Just to provide context to everybody, when you going back to those years where we're using GraphX with RDDs, basically we had a tendency to basically overheat any particular one node in almost every single query. So it didn't matter that you had like a distributed 20 node cluster. One of them would just get super hot and you're just taking it out basically.
Yeah, exactly. And from then on, we realized, and you said my fairly long title, it has sort of a machine learning platform engineer in there. So essentially, one thing we realized along the way, we're not the only ones who have these problems. There's other people out there within BASF who do have these problems. Accessing data, querying data efficiently, you know? And then the ops part comes along and says, okay, all of a sudden, well, now you have a model or you have data and you trained your model with it, but you go into the operations piece. And this is sort of where we come into Delta. And I don't want to bash other technologies here, right?
So don't bash, but you can.
No.
Yeah.
The question was essentially, how do we version data? Because at some, depending on what you do, depending on how relevant it is, you may even want to have like an audit trail. You may have want to have complete sort of backtracing into how did that thing originate. So what I always say is, if you have no versions, you have no concept of progression, you have no life, yeah, in your system. And the same applies to code, data, models, whatever. If you cannot version it, you cannot progress it, you cannot go back and forth, you have no chance. So the question was how to version the data. And we tried things like DVC, which is a great tool just for our purposes, where we want to sort of, the struggle I always had is your version lives with your code,
Right.
But your data doesn't progress with your code. Your data progresses on its own lifetime, and your code may be ideally at some point somewhat static, and you just kind of keep reprocessing things as new data emerges. So, but also, again, coming back to the picture of the graph, right? So we have those huge pipelines where massive amounts of data flow, and this is where we employ Databricks, Spark, a whole bunch of technologies that are capable of handling that scale. But that thing also has leaves, right? So we have a plethora of many little problems that we need to solve. And with problems, I also mean opportunities where we can sort of leverage data, where we can leverage models. But you cannot approach each and every problem with such a massive construct and say, okay, I don't know if that's accurate, but you had a session with Andy Grove
Sure. Yeah.
not long ago, and I saw a session with him once where he sort of compared Data Fusion and Spark.
Okay, sure.
I don't remember the exact numbers, but he said something like, yeah, I ran this on like 100 gigabyte data set, and it's kind of unfair because Spark is made for much bigger data.
No. Actually, that's completely valid. I actually agree with that, because remember, like, the thing about Spark, it's designed from the standpoint of I have to spin up jobs, right? And then those jobs spin up tasks. So there's already an overhead just to spin things up. And then even if I had the data sitting in memory, which almost rarely never ever happens anyways, right? Like, let's be real. That's almost at least a starting case. That's almost never the starting case, right? So I've got to get the data from disk, right? Unless you have that much money and you don't mind floating that in memory. there's physical limitations at some point. And even if there's no physical, there's economic limitations. So it doesn't matter, right? So you have to get that data into memory. So I'm going like, so the startup time to extract, go ahead, chuck, throw, distribute in memory. There is the JVM involved as well too. Like I'm not trying to trash the JVM. I'm just saying it is what it is. It requires time to spin these things up, right? And so now the time isn't like 5 minutes. The time is seconds. But the point is that using, and Andy's right, like, because we actually even shown it ourselves with a bunch of for example, Matthew Powers from my team, he's actually wrote a bunch of cool blogs about data fusion for exactly that purpose. It's like, oh yeah, well, we're talking about hundreds of millions of rows, forget it, there's like virtually no spin up time, grab the data, chuck it in memory, boom, the query is finished before the JVM even started. And this, again, it's not a knock on the JVM. I have my own problems with that, but that's not the purpose of the statement, right? It's like, but if you're dealing with billions upon billions upon billions of rows of data, yeah, you can't shove that into a single data fusion. Like, Andy and I were discussing about, well, fine, we'll just do Ballista, but that's a whole other discussion, which we're going to get to, not today.
Yeah.
Right. So no, I'm for it, by the way, to be very clear. This is not me knocking. I'm just saying that's a much longer discussion, not for the purpose of today. That's all. But that's the context, right? Like, so then of course Spark makes a ton of sense in this scenario, right? And then, no, I'm not going to debate you Ballista if Ballista's worth, it's not production ready yet. Even Andy said that, okay? Do I want Ballista to succeed? Absolutely. So it's all said. So yeah, this is not a knock on that, Ballista. But yeah, to your point exactly, right? So, and just to reiterate your point a little bit, you have not just a bunch of big problems, right? You have also a bunch of like hundreds or thousands of really small problems, medium problems, right? Because when you're building these models for chemical process engineering, chemical engineering, like if I'm making like, I don't know, thread, like thread for plastic rolls or whatever, right? You don't need billions of rows of data for that. This is like probably medium-sized data, right? So yeah, you don't want to, and you have to build different models for different processes. So again, we're talking about thousands of smaller models against smaller amount of data, as opposed to the gigantic, like, oh, we're going to top process everything. Okay, so so that invariably led to, again, you were using Databricks with Delta. That's great for all the big data, but then now you have this many small problem, smaller problem to deal with. So yes,
exactly, and due to the issues we've seen operationalizing DBC, especially in our Kubernetes clusters, where we said, okay, well, tying Git into your deployments and stuff like that, it just kind of, we couldn't make it work to a degree where we liked it. Delta, however, checked all the boxes, right? So the version, the metadata lives with the data, right? It does have, and I mean, we've been discussing this. There is limitations to how you can do concurrency, or getting different systems to do concurrency together. But we'll resolve all of this. But essentially saying, okay, well, great, let's just do this. So pip install Delta Lake. Oh well, that thing doesn't write. And it also doesn't read from Azure.
It does. By the way, it does now. It does now. It does. And Robert helped with that. Okay, so let's be very clear. So just in case you're all going like, oh, it doesn't work. No. He's preventing a story. So at the time he started, it didn't work with Azure and it didn't write. That is correct. It does now. Okay, so please go on.
Yes.
I'm sorry. I want to make sure people are cutting.
It actually does many more things by now.
Yeah, it does. But I just.
But that was kind of getting started.
Yeah.
And back then I hadn't written any Rust ever. I also saw a little bit of Python. I felt very comfortable in Python. Okay, maybe you can do something on the Python side. Did a little bit, but very quickly realized, okay, you'll have to go into Rust.
And why did you have to go into Rust? Oh, okay, sorry. That's actually a leading question. Let's continue on. Sorry, I'm sorry. I was leading on. Forget it. My bad.
I mean, the reason is very simple, because the problems that we wanted solved were on the Rust side of things, and that's where you needed to solve them. But then, to be honest, it lay dormant for a little bit, because I mean, there's a lot a lot of things to do, and there I probably shouldn't share that, but because it makes me maybe not look good. But everybody has like a little bit of an ego, right? And we have this internal code sharing platform. Well, it's a Git deployment. I don't exactly remember which flavor, but anyhow, where you can browse through other people's projects and see things, right? And there's this very talented person in our sort of bio division, and I just saw, okay, he was writing Rust. I'm like, okay, well, now you have to. Now you have to go into this. It kind of gave me the last push to throw away my reservation. Well, I don't want to say reservations, but push me over.
No.
The edge
It's
and
completely fair in all seriousness.
dive into Rust.
Yeah. Because look, I mean, if it makes you feel any better, I literally was fighting. Well, I would say fighting, because that's a little too strong a word, but I was literally debating with Frank Masheri, who was the CTO of Materialize, when he back when we were still at Microsoft together. He was at Microsoft Research. We were working on all things differential privacy algorithms, whole other story, whole other lifetime. But literally, I was debating back with him, like, oh yeah, no, what is this Rust thing? Are you nuts? Yeah. So I obviously lost that debate. So just want to call that out. So yeah, no, it's all good. It's all good, man.
And then I just have to say, there is a learning curve, absolutely, but it also has. I mean, you see these developer surveys from Stack Overflow, right, where Rust is most beloved for, I don't know, X many years. Just
8 years running, by the way. They just released the survey yesterday, actually.
I was going to ask, because I filled out the survey kind of a couple of weeks ago, or I don't remember whether it's still in there. And
no, they just released it yesterday. It just came out yesterday, and again, Rust was the most beloved language. Yeah.
And I know why, because for some reason it does have a pull. Once you kind of pass that threshold where you're just kind of yelling at the screen all the time, and like, okay, what do you want from me? After that, it is really, really nice. It's really, really nice to work with. And the community, I mean, Tyler, QP, all of these, just very, very welcoming, and be like, okay, just kind of engage, and we'll help you along the way. And I mean, you know where that ended up, right? So initially did a lot of work on the Azure support side, so integrating with Azure, which also led to, again, just a great welcoming community. Also on the Microsoft side, kind of looking into the SDKs, met various people through that, and then just do write support really quick. Yeah, how hard can that be?
Oh no, that's easy. What are you talking about?
Yeah. And then that was just kind of something, a new challenge to get excited about. Yeah, because if you go into Delta low level, there's a lot of really, really cool stuff. I mean, the same is true for Iceberg and others, but there's a lot of really cool stuff happening. And then sort of the optimization awoke again, because on the low level, you're again sort of solving mini optimization problems, figuring out, I don't know, how to batch your requests, how to, I don't know, merge ranges, what have you. And I don't know, just was fun and useful at the same time. And from the operation side, and this is me privately just kind of engaging in that, right? But then also from the MLOps side, it does exactly what we wanted to, in a sense that all of a sudden you have versions on your data set, you can trigger stuff on those versions, so your graph of interconnected problems becomes reactive, because Delta announces, hey, I'm new, you should, I don't know, reprocess me, yeah? And a lot of these use cases are actually, if you look into how complex we are with the write today already, I mean, we just had Z order or updates being merged, where you need to do a lot of heavy SQL-like operations. But even before, in the machine learning context, you're just replacing your table, and you just want to kind of I have a new feature table, and give me the next version. So these sort of append-only cases that are already covered with quite a bit, and then it became already useful. And yeah, I'm a fan.
Yes, we're fans too, obviously. That's why we're talking to you. And so part of the reason why I wanted to talk to Robert about his use case was mainly because the fact that exactly as he sort of implied, I mean, he stated, but I want to be stress how invaluable has he become to the Delta community in such a short amount of time. So exactly as he called out, he started fixing the Azure support. I still remember talking to him about that particular code base. In fact, man, that's many months ago now. And then it switched into, yeah, I need write. And it was like, okay, boom. And then literally just like churning through and just pumping out code and maintaining code quality and reviewing everybody else's code, and then also welcoming new people to the community. It's a short order. Like you basically literally just in a short amount of time went from what is this to like now boom, I'm in all the way, which is really, really cool. And so with the remaining little bit of time that we've got left, we got about like I'd say 5 to 10 minutes left here. Let's roll back a bit. So this is cool from a tech perspective. It's cool from a data perspective because you say, oh yeah, this is like really cool. Like I'm actually able to process data because I'm using data fusion. And nothing against Polars, by the way, folks. Polars is really cool too. Yeah.
We actually, since I'm not the one doing the actual data sciencing anymore, one of the things is you use what you want as long as you store it in Delta, and it beautifully integrates with PyArrow, Pandas, Data Fusion, Polars, you choose, right?
Right. Exactly so. And so the context is, okay, well, this is all great fun and games because now it's just geek to geek talking about, oh, let's do data engineering, right? But then let's wrap this all the way back now, right, to how BASF achieves global sustainability with Delta Lake. So all of these processes are to do what? Like how are they helping so that way you can, so it's possible to be a heck of a lot more efficient, or how does this impacts the process engineering itself?
Yeah. So, I mean, there's various aspects to this, and we have to kind of keep it a little bit high level. But
oh no, definitely high level. Yeah, definitely high level. Yeah. We don't want to go into IP territory at all here, guys.
I mean, so essentially, what it does, and sustainability has 3 pillars for us. Yeah, it's economic, ecological, and social. And maybe let's highlight the social aspect of it as well, because I feel like, especially having Delta being that accessible, that fairly easy to use for everyone, unlocked a lot of operations potential essentially for everybody out there. Yeah, you just need to tell them, okay, this is how you use this. And after that, it feels very much like using raw Parquet or CSV or what have you. But the thing is now, the startup cost for approaching a problem, but also utilizing data that has been processed within sort of the big Spark pipelines and that gets sort of served there, became feasible. So the entry barrier for actually doing a project, for actually starting to analyze and interact with the data, is lowered significantly. So from that perspective on, we can actually look into many, many more issues than we were able previously. And still, it's much easier if you do some things right from the beginning to go from sort of, okay, let's have a quick look, into, okay, let's take this to something that is productive. Because on the low level, on the baseline, you're already employing sort of production-ready technologies in a sense that they support all the things you need in order to go into production without incurring much more overhead for the people just doing the exploration, for instance. Yeah. So being able, and sort of popular concepts like data mesh and stuff like this also advocate decentralization, right? They advocate a network of interconnected data products. But also here, I felt like unlocking Delta for everyone who maybe doesn't have a Spark instance ready to go, or wants to deal with JVM Because there is standalone and other solutions out there. It's not like Delta Rust is the only thing that now allows you to read Delta outside of
No,
Spark, right?
but middle enough, the two of us are slightly biased right now.
Yeah, maybe.
A little bit.
So I lost my train of thought here.
Oh, the I think the context you're trying to say is you've already covered social, but you're also talking the economics from the standpoint of
yeah. Okay, so essentially, well, unlocking this for everybody without having this high entry barrier is then, oh no, we were one step further in the data match. They're saying,
oh,
now
sorry, that's right.
we have a federated approach. Federated in the sense that multiple individual entities, they need to be able to talk to one another, right? But they also should be able to process their data sort of independently. And with storage being sort of a very easy to meet common denominator between systems and various environments, right? I mean, it's hard to be in a resource constrained environment and spin up sort of a SQL server really quick or what have you. But provisioning storage is something that is doable in almost any environment you're running. So we can go much deeper into sort of the, how do you call it, nooks and crannies, wherever out there, and process data there, right? So from that perspective, obviously we make it more accessible. We do save resources, and with resources we do make a contribution. It's not going to save the world, but we use less compute, and that has an impact on the environment, right? I mean, it's just not, we need to do more, but we always want to be mindful of it. We never want to be wasteful. I mean, that's sort of a common mindset. We are also a commodities company, but we never want to be wasteful. And I feel sometimes you maybe. So I feel it pays into all of these goals on a very broad spectrum.
Yeah, no, I love how you're talking about that, because the whole point, just to reiterate, is that by using, and again, we're slightly biased on the Delta Rust side, but the fact is that with Rust, it allows us, I'm in just the general Rust community, but and then obviously for BASF, for them, just use a heck of a lot less resources. And because you're using Rust resources, you can actually literally go to every smaller system and figure out how to optimize it better. So now you're losing less energy to optimize more systems. The optimizing more systems themselves means that all of a sudden we're actually able to use less resources, whether it's the actual raw components to actual energy, which means when you're producing said resources using less energy, all the more better. So, and we, for example, Christian had from Script, he's also a Delta Lake maintainer. Like, he actually had a session, I want to say 2 years ago, on Kafka Delta Ingest, where he's talking about how they were able to go ahead and then also, for that matter, QP and Tyler were also talking about the same thing, where basically they went ahead and went it's like 2 orders of magnitude cheaper on processing Kafka topics because they were using Delta Rust. And so it's sort of very behooves us to understand that there's a lot in play. And so it's not just about, oh, I process the data. It's about the fact that you can actually do social good, accessible, open, economically better, and all these things put together. And so, and then I guess that is the whole context of, hopefully I'm saying it right because I'm not German, Verbund, right?
Yes. Synergize wherever you can.
Yes.
And
I'd rather use Verbund just because synergize is now too much of a marketing term. I don't want to use
it. Exactly. Yeah, no, that's it. And I mean, there's a personal aspect to it as well, because it's just fun to do. It's just a fun set of problems. I like Databricks as, what do you say? Like, solve the world's toughest problem.
Yeah. Helping to solve the world's toughest problems. Yes, exactly.
I'm not saying this is one of those toughest problems, but it solved a lot of tough problems. And one of the things that we kind of from the internal platforms now try to do as well is, okay, let's try to solve the tough problems for everyone that everybody spends a lot of time on. And unlocking how people work and interact and process data is still one of the major time wasters. Not because the people are unable, but sometimes even, yeah, there's many facets to that, right? But for us, unlocking the data securely and performantly and economically was one of the tough problems, and that's a big piece in solving it.
This is perfect. Okay, so I think this is a great way to end today's session. I did want to do a shameless plug-in, shout out to, you can chat with Robert and myself directly in person, actually, at Data and AI Summit at the end of June. It's going to be held in San Francisco at the Moscone Center. And so you want to talk more about Delta Lake in person, you can always join us there. Otherwise, you can also always join us virtually at go.delta.io/Slack. So those are easily the best ways to find us. We're on that Slack almost all the time. And then, like I said, in person, Data and AI Summit. It's 10 days before the conference. So I'll finally get to meet you in person too, which is really going to be really nice.
Absolutely. Looking forward to that one. Yeah.
Absolutely. Well, then that's it. I think we're going to call it a day today. Thank you very much for listening to this awesomely fun session. Yeah, that's it. I think we're done.
Thank you for having me.
Perfect. Thanks a lot, Robert. And we can just leave right after we're done, and see you in 10 days.
See you then. All right.